During the course of the rest of the semester, we're going to use both Dynamo and Grasshopper to look at some more custom kinds of things. So you're going to want to be familiar with at least roughly how it works. So in this script, basically what we want to do is just bring in those two. We're going to start out by bringing in those two mass floor shapes. So these are each faces that we're going to use as our reference points. And those faces can move. Obviously, if you move the levels inside of the conceptual mass, you might think of this as being somewhat parametric, because you can always adjust the level height and the elevation, and the mass floor will move with it, and you could imagine sort of adjusting the height of the components as you go through this. The script that we're going to write, it's important to be conscientious of the fact that it's only for 2 floors, but that you could quickly adapt it to use if you were to set tension rings at every 4th floor. You could take all of the tension rings, all of the mass floors that represent those tension rings, so say floor 4, floor 8, floor 12, floor 16, and to use this script to do the entire thing. We'll maybe talk about that in class. So here what we're going to start off with is just using a select face. So you're always going to type what you're searching for into the search bar here, and then click it. That'll bring it in, and we need 2 of these, so I'm going to hit Control C and Control V. And if you've never used Dynamo, it's again a lot like Grasshopper. These components are going to have little wires that we can tag into the next component as you move across. So with the select face, I can hit the select button and then move into Revit, and I'll tab until I can select the mass floor that's on top, and then go to the other select button and again tab to get that mass floor. And you'll see that we do get, should see some blue here, and blue is just indicating a piece of geometry that you have selected that corresponds with the component you have selected. So these 2 buttons at the top allow you to toggle back and forth. Let me make this bigger. Allow you to toggle back and forth between working with the script, which are these components, and working with or visualizing the geometry. So if I hit this little geometry button, I can scroll around. I'm holding Command, or I'm holding the right mouse button in order to spin around, panning with the middle mouse button, and zooming with the middle mouse wheel. And you can see how my components fade out. And I can hit the components back, and now I'm again modeling, or I'm moving around within the 2-dimensional field of our script. Okay, so these are going to be relatively simple kinds of moves that we're going to do that are going to make this a parametric thing. The first thing that we want to do is to get the perimeter curve of the surface. So this return all the boundary curves of the surface or around the for each of the components. So I'm going to go take the surface and put it into this, and take this surface and put it into that. You can hit the little square button here to see what you're getting from each of these. And you can see that we're getting 4 lines that represent the boundaries. That's because we're starting with the square and heading to a circle. And you can see here there's a small straight component even of this mass floor. So I'm getting 1 arc, 2 straight, 3 arc, and 4 straight. Sort of like the lower one here. So we need to join all of those to get them to operate like a single curve. So we're going to do a polycurve from curves. So you can read the little description over here as I'm typing it in. It's basically a polyline. So it's a polycurve returns curves of the polycurve, or of the curve returns. This is backwards. So we want to create a polycurve from a set of curves. Polycurve by points, polycurve fillet, polycurve deconstruct. Here we go. Join this curve and the input curve. No, that's gonna polycurve, number of curves of the polycurve. No. So you can see here how quickly you can get sort of screwed up because of the names of components. And I don't pretend to think join this curve and the input curve. I think that's going to give us only 2 options to actually join Yeah, so when I do that one, it's giving us two curves. We don't want that. Let's see if polyline gives us anything. Nope. From curve. Don't want to deconstruct it. That one's looking for... I'll make you sit through this. Again, sorry, this is just not the most ideal naming devices for a lot of the chunks of the scripts here. So the one that we need is to create a polycurve by joined curves. And so this is going to take a curve component, which is coming out of this one, and putting it into that to create a single curve, which is our goal. And we're just doing everything twice here. So I'm hitting Control C and Control V to kind of keep marching along. Now we're going to divide these curves to get the points where our diagrid would actually touch. And we want to divide the curves equally. Divide the curves evenly along the parameter space. Divide equally, I think, is the one we want. When I click that, it comes in. Delete that one. Again, we'll make a copy. And the number of divisions is going to be important here, and I'm going to use, this is one spot where Dynamo is different than Grasshopper. Dynamo cares a lot sometimes in certain components as to whether you're feeding it an integer or a number. And in this case, the divisions want to be even, so we need to give it an integer. And in that case, you need to grab an integer slider. And this integer slider, we want to control both levels of this. So I'm going to plug it into both pieces. And when I select these, you can see, it's still just representing the curve. You can turn the preview off, much like you do in Grasshopper, where you can select a component, right-click it, and say preview, and preview, and uncheck the previews along the way to see what we're getting. Looks like I'm missing a little line segment there. I'm going to put a close with line on the poly curve and see if that completes the curve. There we go. I'm going to put one of those on each one before the divide curve. So this poly curve goes into the poly curve close and then into the divide. So again, both the top and the bottom are exactly the same. And what I'm looking to find here is that I've got a list of 13 curve components in each of these that I'm going to use as the points for eventually for the diagrid. So now we need to get an endpoint from each of those curves. So curve endpoint. The curve goes into the endpoint. These points will be the actual connectors from curve edge to curve edge, or from floor edge to floor edge. And I'll hit these, close these up. Now, in order to get what I want to show quickly is that you can create a line between these points. A line by start and end point. And if we just plug these two in, you can see here what we get, which is a series of curves moving around the component. If you're doing this and it's getting really buggy, down here in the bottom left, Grasshopper does this by default. It's always running, it's always updating the script unless you disable one of the components. Down here you can actually turn this over to manual, but then you have to hit the run button in order to see the results of the things you're doing. So if your script gets difficult or gets large and you're waiting, so you just saw we waited there for a minute for it to draw those lines, you could switch it over to manual. Shouldn't be a problem for what we've got going here. Okay, so what you can see is that we're already tracing the kind of the lines back and forth between our two tension members or tension rings around the system. So what we need to do now is to control the way or the location in which these lines actually start to move, and we need to make another set, which is creating the X geometry across the facade. What we're going to do is use a shift indices. What that's going to do is basically take our list of endpoints here, and it's going to shift it. So when I put it into this and then take a look at the I need to give it an integer for how much, and I'm just going to set this on, say 1 for right now. Put that into the shift list. It should be shifting the points along. I know what it is. So just as with Grasshopper, there's oftentimes the list information that you've got doesn't align with one another perfectly, and so with Grasshopper you're often having to flatten a list or graft a list to match things up. In Dynamo that's done the same way, but different rhetorically. You need to hit the little dash here or right click on the component and change. Oftentimes you'll have to change the lacing, and the lacing is basically saying, do you want to use the shortest list, the longest list, or to combine all of them? So combining all of them would be like grafting. Using the longest is simply saying use the longest of the versions of the list. And you can see here what it did is it took the last component from the original list and it made it the first, and it shifted everything else down one. So that's all we're doing with this shift indices, is just shifting the list a little bit. And now when I put that in as the start point for the curves, you can see how they start twisting around the geometry, approximating more of what you might imagine the components looking like from a diagrid. So same thing goes now. We want to basically do another couple of versions of these to get the X moving across. So I'm going to take and copy this component and do another version here that's shifted. And now I'm going to make another line by start and end point. And this one's going to go from this shifted list to this original list, so that we get the kind of cross members moving back and forth around this geometry. And again, this is intended to, it's not perfect. You can see that there's kind of a line jumping across. If you play around with the shifting, you can get this to work a little bit cleaner. And it also has to do with the number of points. So this is just one set of diagrids that then you could use moving all the way up through your tower from tension ring to tension ring. It's a really simple kind of script. You can certainly get much more complicated as you start to make things further on down the road. I do want to show something that works, I think, probably as good as the script, but at least now you understand. Now that you understand a little bit about how you might go about aligning the geometry and taking control over it. So again, if I shift this to 2, you're going to see that I get a different approximation of the facade. And as well, I can change the number of members over here to get it closer to the kind of diamond pattern that I would be expecting for the diagrid. Okay, so there's a lot of when you load Dynamo, as with Grasshopper, there are a lot of other plugins. Up here at the top under Packages, you can go to a search for package, and this takes a second, but it syncs up with the server and tries to, and will show you a bunch of exterior packages that people have provided or written. So the first one, there's one in here that's called Diagrid by a guy named Wasim Jabi. It's not. It doesn't seem to be working right now. It's driven by a Python script that seems to be relying on a library that's no longer built into this. So if you type the word Diagrid in here, you're going to see those components. I'm trying to get it fixed, and if I do, I'll send it your way. There is another one, though, that's in the Lunchbox component. So Lunchbox is written by a guy named Nathan Miller. Incredibly useful tools, both in Grasshopper and in Dynamo. Lunchbox. It's been around for Grasshopper for a long time. It's relatively new now for Dynamo. So you hit the little down arrow, and it'll install that package for you. And what you'll see once it's installed is that it's sitting over here in the drop-down menu. And there is a component in here. If I type in Diagrid, there's a Lunchbox Diagrid structure. And I'll show you what this looks like. Like if I zoom in on it and double-click it, it actually opens up a series of components that are inside of it. And again, it's a Python script. This Python script this one does work, and it's relatively clean. And it works basically in a similar fashion to what we just did, but by using a surface, the surface outside surface geometry, rather than the tension members the way that we did. I won't go through that whole script, but in essence, you can see what's going on here. It's looking for an input, a U and V division across the surface, and then this input, a Boolean, is just telling it to trigger the function to get things started. So I'm not gonna change that, but I will show you quickly how this works. So again, we'll need a select face from inside of Revit. So I'll pop back out and I'll use the select face. I'll hit select. This time I'm going to select one of the faces of the mass, and you can see it kind of come in. It's still aligned with the other Diagrid piece that I've been working on. I guess I'll leave that until it gets messy. So this surface component goes in there, and then we need another integer slider. You guys are going to be frustrated when I show you this, but I made you go through the other version of it. Anyway, you hit the slider. I'll set it to around 8 or so, and then the type Boolean just requires a Boolean trigger, which is just a true-false input. So I'll bring that in, plug that in here, and if I flip it over to true, then you're going to see the Diagrid snap to that face. I'll scroll to the geometry here, and you can see that it's basically dividing across the facade. And if I change the integer slider, it's going to change those facets as it moves across. It's not perfect, you can see how it compresses down here, but it does work relatively well, and you can do it on a series of different facades, different kinds of geometries moving around the object. Anyway, so a couple of ways to start. These two are basically doing the same thing. This one's using a surface, the other one's using your tension members. So if you're really concerned about aligning with your tension members, you'll probably want to do the longer script, or you need to do some math in order to figure out how to get this Lunchbox Diagrid structure component to actually align with your tension members. All of this is assuming that you're trying to maintain some control over the alignment of the tension member with the floor plates. If you're not, you got a lot more freedom, and you can do whatever you want, really. But here, these typical kind of off-the-shelf components are inevitably going to give you some frustration because you can't align those things up with your building organization, your floor plate structure. Okay, that's it for this one. Thanks.